Hi, welcome to the course Big Data Analytics. In this lecture, we will discuss about importance of big data. Coming to the outline, here first we have to discuss about when to consider big data as a solution, then some real world big data use cases. That is IT for IT log analytics, the fraud detection pattern, then social media pattern. Big data analytics, as we already aware, big data is more real time in nature than traditional data warehouse applications. Traditional data warehouse architectures, for example, Exadata, Teradata, which are not well suited for big data applications. Here, shared nothing, massively parallel processing, scale out architectures. These are all some of the tools which are well suited for big data applications, where traditional data warehouses not supports these type of big data applications. Then coming to importance of big data, whenever data is more, then we have for analysis, then the greater will be the analytical accuracy, and also the greater would be the confidence in our decisions based on these analytical findings. So how to entitle this one? With a greater positive impact in terms of enhancing operational efficiencies, reducing cost and time, and innovating on new products, new services, and optimizing existing services. So in this way, you can achieve that. Finally, whenever data is more accurate analysis is required, then greater confidence in decision making, then greater operational efficiencies, cost reduction, time reduction, new product development, and optimized offerings, etc. So whenever data is more, these are all the required operations. That's why big data is very important. Then when you have to consider big data as a solution, there are some key big data principles. Firstly, big data solutions which are ideal for analyzing not only raw structured data but semi-structured and unstructured data from a wide variety of sources. Big data solutions are also ideal when all or most of the data needs to be analyzed versus a sample of the data or sampling of data is not nearly as effective as larger set of data from which to derive analysis. Then also big data solutions are ideal for iterative and exploratory analysis when business measures on data which are not predetermined. These are all the key big data principles. Then solving information management challenges using big data technologies. We have to consider the following. So here we have to raise the following questions. Is the reciprocal of the traditional analysis paradigm appropriate for the business tasks at hand? Better yet, can you see a big data platform complementing what you currently have in place for analysis and achieving synergy with the existing solutions, which are better business outcomes? So we have to raise all these conditions. So whenever you are solving information management challenges using big data technologies. Also, big data is well suited for solving information challenges that do not natively fit within a traditional relational database approach for handling the problem at hand. This is the another way of consideration big data technologies for solving information management challenges. Then coming to big data real world use cases. The first one, IT operations, then security, compliance, infrastructure, competitive undermining. These are all some of the real world use cases. While coming to IT operations, first troubleshooting connectivity, outage troubleshooting, application monitoring or tracking, service level confirmation for IT outsourcing. Security perspective, centralize a log or event management platform, security, fraud detection. Then compliance, PCI compliance, retention compliance, service level confirmation for IT outsourcing. Coming to the infrastructure, log management here, applications, SOA, that is service oriented architecture, microservices, then software as a service. Then transaction tracing, root cause analysis, visual analytics on mission data. Then competitive undermining, filtering or cost avoidance solutions. And these are all the various real world use cases and their operations at glance. If you can see in detail about the three case studies, IT for IT log analytics, the fraud detection pattern and social media pattern. Let us see. IT for IT log analytics. Here, log analytics enables IT operations analytics for machine data. Then correlation of events is the key for added business value. Log management is the complementary to other big data components. If you can see the flow of IT analytics, so here bottom you are having time of action. First you are having log management, then IT operations analytics, ITOA. So here this task is called as log analytics. Then here next flow is here first data warehouse, then streaming analytics, then data discovery, then Hadoop, variety of different frameworks. Then here historical data is considered, near real-time data, and then real-time data, then predictive prediction. So this is the one of the example of flow of IT operations with their log management. Here log analytics is defined with respect to the time of action. So in this here you can see visually various parameters considered here. First, service level assurance, then the compliance, then security, then IT operations, then business activity. Here, service level assurance, same information being stored multiple times. That means more hardware, more cost. Whenever you can do this one, these are the problems. Then finally, redundant solutions create network burden by collecting same data multiple times whenever duplications are allowed. So these are the various levels of IT for IT log analytics operations. Then if you can see here, by including log management here, service level assurance, compliance, security, IT operations, business activity. Among all, here you can see the log management, the log data is stored here. Then the data can be analyzed based on the operations from the various aspects or various levels. If you can see the characteristics of IT log analytics with respect to data sources, log information with standard protocols like TCP, UDP, file, syslog, etc. Then all events like logs, messaging, streams, etc. Then extendable plugins like connectors, SDK, APIs. Then features collect, parse, correlate, search, report, forward, etc. Then store and index. Then query language like SQL custom along with the sliding windows, correlations, etc. then retention, then compliance templates, then frequency with respect to historical data, near real-time processing, seconds or minutes. With respect to deployment options, on-premises versus cloud, that is SAS, software as a service. Then open sources versus commercial, software versus hardware appliance. Finally, pricing perspective, free, that is open source versus CPU based versus volume based. Here you have to be careful that IoT data grows exponentially. These are all some of the characteristics of IT lab analytics. Then coming to the next use case, the fraud detection pattern. Actually, the fraud detection comes up a lot in the financial services particular. But if we look around, we will find it in any sort of claims or transaction-based environment with respect to online auctions, insurance claims, underwriting entities, etc. Anywhere some sort of financial transaction are involved, which presents a potential for misuse. If we use a big data platform, we have the opportunity to do more than we have ever done before to identify it, or better yet, stop it. There are several challenges in the fraud detection pattern are directly attributable to solely utilizing with the conventional technologies. One of the most common and recurring theme we will see across all big data patterns is limits on what can be stored as well as available computing resources to process our intentions. Suppose without big data technologies, these factors limit what can be modeled. Whenever less data equals constraint modeling. If you can see, this figure shows traditional fraud detection patterns use approximately 20% of percentage of available data. Here you can see you are having traditional data sources like ERP, CRM, databases, etc. Here DB2, Informix, IMS, SolidDB, these are all the various databases. Then we have service-oriented web services, get customer, get price, calculate discount, calculate risk by seeing traditional data sources. Also, data quality or governance with IBM information server. Here, data warehouses, ODS. So, which takes from the traditional data sources, then from SOA web services. Then here, fraud analytic models are defined with multidimensional services, then by combining all mashups and applications. So this is traditional fraud detection pattern, which uses approximately only 20% of available data. Same if you can, let us see here, a modern day fraud detection ecosystem that provides a low cost big data platform for exploratory modeling and discovery. Here, one of the important note is how this data can be used by traditional system, either directly or through integration into existing data quality and using some governance protocols. This is the another representation, a modern day fraud detection ecosystem synergizes a big data platform with traditional process. Here you can see the difference between previous traditional to this modern day fraud detection ecosystem. Here, in addition to the previous one, here you can see big data is used here. So big data. So here, InfoSphere, big insights, big data repository, and processing. These are all the big data tasks. So remaining everything same here. Fraud analytic model, massive up application, multi-dimensional services, SOA web services, traditional data services. Here data quality governance with IBM information server. Here additionally big data is used here. This is the modern day fraud detection ecosystem, which synergizes a big data platform with traditional processes. Here one of the important note is the addition of InfoSphere streams here, the circle by the DB2 database cylinder as well. which showcases the unique big data platform that only IBM can deliver. It's an ecosystem that provides analytics for data in motion and data at rest. Then coming to the social media pattern. The most talked about big data usage pattern is social media and customer sentiment. Social media analytics is a pretty hot topic. So hot, in fact, that IBM has built a solution specifically to accelerate our use of it with Cognos Consumer Insights (CCI). This CCI is a point solution that runs on big insights and it's quite good at what it does. CCI can also tell us what people are saying, how topics are trending in social media, and all sorts of things that affect our business. Finally, all packed into a rich visualization engine. All the basic insights into social media can tell us what people are saying and how sentiment is trending. They can't answer what is ultimately a more important question. That is, why are people saying, what are saying, and behaving in the way they are behaving. So this is one of the important question in social media to define basic insights. So answering this type of question requires enriching the social media feeds with additional and differently shaped information that's likely residing in other enterprise systems. Simply, you have to put linking behavior and the driver of that behavior, which requires relating social media analytics back to our traditional data repositories, whether they are SAP, SAP, or DB2, or Teradata, or Oracle, or something else. Again, linking with our traditional data repositories. Here you can see in social media pattern one real world example. So one of these books author, that is the Tom White, is a prolific Facebook poster. For some reason, he thinks the world is interested in his daily thoughts and experiences. After a number of consecutive flight delays that found their way to his Facebook wall, he was contacted by the airline to address the sentiment it detected. The airline acknowledged the issue, and although we won't get into what they did for him, think here more legroom. So the mere fact is that they reached out to him meant someone was listening, which somehow made things better. This is the one real incident happens with the Facebook poster. So here you can think watching the old record Twitter tweets per seconds (TTPS) index is a telling indicator on the potential impact of customer sentiment. This is another example of social media pattern, that is Twitter tweets. So Super Bowl 2011 set a Twitter TTPS record in February 2011 with 4064 TTPS. So it was surpassed by the announcement of Bin Laden's death at 5106 TTPS, followed by the devastating Japan earthquake at 6939 TTPS. Here you can see initially starting with the 4000 plus tweets, then that is surpassed with 5106 tweets, then that is surpassed with 6939 tweets. Like that, here you can see how the tweets are increased. Also, another record that this Twitter record fell to the sentiment expressed when Paraguay's football penalty shootout win over Brazil in the Copa America quarterfinal peaked at 7,166 TTPS, which could not beat yet another record set on the same day, that is US match win the FIFA Women's World Cup at 7,196 tweets. Here you can see these are some of the real-time tweets examples. So these records are very telling, not just because of the volume and velocity growth, but also because sentiment is being expressed for just about anything and everything, including our products and services. Truly, customer sentiment is everywhere. Just ask Lady Gaga. So this is the tweet address, Lady Gaga, who is the most followed Twitter in the world. Finally, what can we learn from this? First, here everyone is able to express reaction and sentiment in seconds, often without thought or filters for the world to see. And the second one, more and more people are expressing their thoughts or feelings about everything and anything. So this is the conclusion what you have to learn from this social media pattern. So that is about importance of big data, followed by some of the big data use cases. In upcoming lectures, we will come with other new interesting topics. Stay tuned for latest updates.